If you've seen any of my videos, you'll know that I'm a huge fan of QRP Labs radios. They're amazing, and the QCX Mini is what got me back into radio after a 40-year break. So I'm a big fan, and I encourage everybody to buy them, build them, buy it ready-made, whatever you like. You'll love your QCX or QMX or whatever you get from QRP Labs. So my latest interest is the QMX. Here's one I have which works beautifully, but it's not in a case. I also have one that is in the metal case, which I take out on trips with me and so on. And I was very interested by this for its multi-band use, its various diagnostic features, including a built-in SWR test, and also its ability to do multi-modes such as SSB. Now, I normally work entirely in QRP CW, but I was so intrigued that something this size could do SSB that I decided to make my own microphone, an electret microphone, and I made it comfortable and brightly coloured and easy to use and take around. So if you're interested in that, take a look at my website, q26.co.uk. But that's an aside. This is really about getting these radios going and testing them. So when you build one of these radios, sometimes people find they don't start up straight away and there's some kind of issue with the power. And the boot up process, the startup process, follows a sequence of the voltage coming in, pushing a button, a regulator being triggered, and then the processor being triggered, and then more regulators being triggered. And it's all on two little tiny boards. These are really clever, these power supply boards. And if you're testing the radio, you may wish just to test these to eliminate them from the problem-solving loop. It is possible perhaps to short a contact out, or have a not very good contact, or possibly just touch something it shouldn't. For most people they're probably fine, but it's worth just doing the test. Now, luckily for us, there's a lot of information online from a community of people who support the use of these radios. One great place is Yahoo Groups, and there's lots of other stuff around, and of course wonderful resources on QRP Labs' own website. And when I met Hans Summers last year, I said to him I really wish one day he could write a book or publish more of his material, because it's very well written and very interesting. And the manuals for some of these radios actually make a really good electronics course. I've learned a lot from them. Anyway, one of the fantastic resources I found was this diagram somebody made showing all the pinouts of the PSU boards and how they connect to the main board, and a little description of the power startup sequence. So I'm very grateful to this person. I'll try and remember who it was and look it up and put it on the screen. Thank you. And this has been really useful. And also somebody else wrote or maybe it's the same person, I will check, a fantastic method for checking these boards away from the radio. And all you need to do is get some jumper leads, a breadboard, and you need a controlled power supply so you can regulate the current, and a multimeter, and you can test these boards away from the radio without doing them any damage. Make sure they're all working, and then eliminate them from the problem-solving loop. So that's really useful. So now I've already videoed the test I did. This is all a bit out of order, so let's switch over to that, and I'll run through the test for the 4-pin x2 board and the 3-pin x2 board. And if you're unsure about doing this, maybe it will make you comfortable about doing it. Maybe it will make you think, oh, I don't want to do that. I'm not recommending you do it, but I'm showing you I've done it and it's safe and it worked, and I hope it's helpful to you. So without any more chatting, let's look at the video of doing the tests of the PSU boards. So I'm ready to test the first board, and you can see I have several of these boards, and I'm going to test the one with 4 pins across first, PCB 1. And this initiates the boot up for the QMX. It turns on the initial power and lets the voltage in to start the whole process. So it has 8 pins, 2 rows of 4. So I've connected them all to a breadboard, and I've used male-to-male DuPont leads, jumper leads, whatever you want to call them. So the first thing is the red one, which is the voltage in, is on the red rail of the breadboard, and the black I've connected, which is the ground, is on the ground rail of the breadboard. I've connected the multimeter ground to the breadboard rail, and I've connected the PSU to the red and black rails, and the tests suggest 5 volts at a maximum of 100 milliamps. So there it is. If I press the current button, we'll see 100 briefly flashing, and it won't show any more current until we actually draw some. Okay, so just to complete the setup, there are 6 pins left, and I've put the top ones in a row and the bottom ones in a row, and I've put an LED in series with this 12 volt line or V-in line, so that if it does have a load we can show it and draw some current on the screen. Now this is called the 12 volt or plus 12 volt line, but it actually is the same voltage as that coming in. So in this case it will be 5 volt. If it switches on it will have 5 volts. You can see I put a couple of resistors in because the test later on recommend taking these pins live through resistors, so 47k resistors, they're ready to go. And this is the power on connection, and that sometimes needs to be pulled to ground. So I'll use another lead to pull that to ground, and then I can measure the various voltages with my probe. And let's just have another look at it. There's a couple of MOSFETs and so on all ready to switch the power. Right, so here we go. Now on this sheet, which is from the QMX wiki, I've done number 1, the suggestion number 1, which is connect the power. And now I'm going to section 2, which tells me to connect the power on lead, that's the white one here, to ground, and that should turn the power control FETs on, and the 12 volt pin or the line in pin should show 5 volts, and the VCC should remain at 0. So let's do that. I'll just pop a lead in series with this and connect it to ground, and we should see the LED come on. There it is, and it's drawing some current, 10 milliamps. And now let's test the voltage. The voltage is the same as the line in, or just under 5 volts. And VCC, is that still 0? Yes it is. So that's test 1, if you like, or section 2 on this piece of paper complete. So let's just take that out again, because it says for section 3, which is the next test, disconnect the power on and pull power hold, that's this one, high through a resistor 47k. So when I do that, this 12 volt line should again show the voltage coming in, which is 5 volts, and VCC should be at 0. And this mimics what happens when the MCU, the chip in the QMX, switches on the power from the software. So let's try that now. So I'm going to take a lead into hold. That's right. And I'm going to connect it to live. Yeah, we've seen the LED come on. So this is now 5 volts and VCC is still 0. I'll just check that I've done everything. Yep, and so that is fine. The second test we've done, which is section 3 on this piece of paper, has worked fine. So now I'm going to take this one out of the live, and for the last test we're going to take power on again to low. So I'm going to do that, and I assume that the light will come on again. Yep, because the MOSFET is now switched on, letting the current through, and we're going to pull PWM 5 volt high. So that's this connection, PWM 5 volt. Let's put the line in. Whoops, I missed. Let's put the line in and connect this to live, and we see a little flicker. Now let's do the tests. VCC, which is this one here, should show 5 volts, and there they are, near as damn it. And then ADC 5 volts, this one, should show half of that. There we are, just about 2.5, so that's correct. So that's section 1 is connecting the board to power. 2, 3 and 4 sections are the tests, and they're all complete and they're all okay. Now I need to test these other ones, so I have a couple more boards to test, which I'll do off camera because I've already done one as a demo, and then I'll film again and test the second board, which has 2 rows of 3 pins. Moving on to PCB number 2, and this has 3 rows of pins on the top and the bottom. My other tests were very successful. All these 4-pin with 2 rows PCBs were fine, so that's really good, and I can eliminate them from any problem solving issues. So once again, I've connected live to the appropriate pin and ground, and that leaves 2 at the top, which are here, and 2 at the bottom, which are here. And for the VDD 3.3 volt line, I've connected the LED because the test asks us to check if it can draw some current, and the current should show up on the power supply as well. So now it suggests starting with 5.6 volts at 100 milliamp. Let's turn it on. And yes, we're drawing current. In the region they're suggesting 45 to 55 milliamps. And the voltage should be 3 to 3.3, but it might be a bit lower. I know it is 3 on VDD. So that first connection and test is correct. So the next thing to do is drop this line here to ground. So I'll just put the jumper lead in, and that should pull VDD to ground and the light should go out. Okay, so I'm doing it by looking at my LED, but if you don't have one connected, you can just check the voltage, and it may not actually be 0, it may just be reduced, but it has pulled it down. So that's what we were looking for. And the next test here, which is section number 3 on the test sheet, says reduce the input volts to 3.5 volts. So I'm going to turn it off, disconnect it, turn it back on, just so I don't make any mistakes, and turn this down to 3.5 volts and reconnect it to the power supply. So we pull this one low again, and we're going to pull this one high. This turns the SMPS on, simulating the 100% duty cycle, and VDD should be the same as the input volts. Here it is. Yes. And ADC 3.3 volts should be half. There we go. 1.7 times 2 is about 3.4. 3.4. So this test is correct. So all those tests are correct. It came on, it drew current. When I connected this line to ground, it 3.3 volt dropped, VDD dropped. And when I connected this one to ground and this one to live and reduced the voltage, this line started to operate again. So everything is correct and this board is fine, and now I can connect the rest and test them. So I finished the tests, and it was easier and smoother running than I anticipated. I'm happy that all the boards except one actually are okay. One of the 3-pin ones didn't quite work, and I'm not sure why, so I can look into that. But one thing I will do is put that to one side and make sure not to use it in a radio until I've figured out what the problem is. So it has been a very, very useful test. So as I mentioned earlier, I've been making microphones. Lots of people have bought them all over the world. They're really useful. If you'd like one, please go to my website, www.q26.co.uk, and I'll be back with more videos soon about amateur radio, electronics, QRP Labs radios and things like that very soon. Thanks for watching.